B of the gas law lab. So we're looking at Amonton's law, and we're really looking at how temperature and pressure are related. So I'm going to copy this into Excel, this little table. After I collected my temperature and pressure data, we'll go over to Excel, start a new tab, paste that in there. Good. And the first thing I want to do is convert all these temperatures to Kelvin. So I'm just going to equals that number plus 273.15, sure, and copy that down. And then for pressure, I know that I have that conversion factor that I looked at in part A, kilopascals, and I'm just going to multiply that by my conversion factor, 0.145038 for PSI. And then I'm going to drag that down. Good, so now I have pressure and temperature. And what I want to graph is pressure versus temperature. So I want pressure on my y-axis and temperature on my x-axis. So I'm going to go to Insert, Chart here, Scatter Graph, it's blank again, and then right-click on that, select my data, go to Add, and on the x-axis, I want temperature in Kelvin, and on my y-axis, I want the pressure in PSI. Good. Okay. Great. And that's my graph. I'm going to Amonton's law. Sorry. Amonton's law. And I want to add my axes titles. On the bottom, my temperature, Kelvin. And over here, I have my pressure, PSI. Great. I can add a trend line. So again, I just right-clicked, add a trend line. I can set that equation on the graph. There it is. Boom. And that's my graph. Now, one thing that they want you to look at is, how do I, if I were to extend this line over here, can I figure out if I have absolute Kelvin at zero pressure? So the way to do that, I'm going to click on this again, and I'm going to format my trend line. And if I just bring this down here and I say go backwards, maybe 300 or so, because I knew that might, just basically extending the scale over here so I can see where the y-axis, the zero, crosses the x-axis, where the zero pressure would be, right? What temperature that would be. So it's actually a little bit less than absolute zero. So it should be about zero, depending on how good your data is. You can figure this out by setting the y, the p, right here to 0, and then solving for x. So I can walk you through that. I have that graph written down, 0.0475 plus, yep. Okay, so just to figure out what that would be. Right, so does your graph show that pressure and, yep, so as long as it's a straight line, we would see that pressure and temperature are directly proportional. Let's go back to our graph. I should have copied that over here. So copy, and paste it into your data sheet. You can just put it down here if you want. Great, there it is. And now we can refer back to it. So does your graph show that pressure and temperature? Sure, pressure and temperature. So I increase pressure, I increase the temperature. And that's what we saw when we got in the hot water, then the pressure really went up. So yes for that one. And then for absolute zero is 0K. What is the temperature reading when the extrapolated line goes through 0 PSI? So pressure is our Y, right? So if I set this to 0, and I have 0 is equal to 0.475x plus 0.705, and I solve for x, that would give me my temperature. So negative 0.705 is equal to 0.475x. Now we'll divide both sides. There we go. Divide both sides by 0.475. and we end up with x is equal to about negative 14.8584 k here. So it's about 0. In this case, my numbers were not fantastic. You should get something around 0. That's about 0.